Greetings everybody. Welcome to the next lesson in the exponents unit. Today we're learning about powers of quotients. What's a quotient? A quotient is representing division. So when I'm talking about a quotient, I'm talking about you guessed it, a fraction. As you can see here on this slide, there's lots of fractions being raised to powers. That's a power of a quotient. I'm going to go over a few of those examples, and then I have a series of mixed review questions as we try to keep all of these properties straight. After you're done with this video, you're going to work on a review assignment on Schoology. We have one more concept with exponents to learn next week. That's negative exponents, and zero exponents. That's next week. And then after that, we'll be gearing up for some kind of short Schoology assessment, kind of like we did for the Pythagorean theorem. So that's what's coming our way here. Let's dive in today. So if we look here where it says part 5, that's where we will start today. It says write an expanded form first. So I'm going to expand this out just like I did when I was showing you guys the properties for exponents earlier. So if I had 1/2 to the 4th power, that's the same as 1/2 times 1/2 times 1/2 times 1/2. That's what it means, right? It's 1/2 multiplied it by itself 4 times. And as you may recall from multiplying fractions way back when, you multiply the numerators and you multiply the denominators. What does that result in? 1 over 2 times 2 times 2 times 2. I'm going to write that as 2 to the 4th power right now. And 2 to the 4th power is 16. So 1 over 16 would be my best answer right there. Now, let's do the next one, and then we'll kind of pull this thing together. 2/3 to the 3rd power. That's 2 times 2 times 2 over 3 times 3 times 3. That's like 2 to the 3rd power over 3 to the 3rd power. Let's look at the original problem and see how maybe we could have gotten that right away without having to expand everything. So if we zoom in on this, it's almost as if this 3rd power right here was applied to the 2 and the 3. That's exactly what happened. Well, right now, this is currently a 2 to the 1st power, and this is a 3 to the 1st power. And as you remember from raising a power to a power, you keep the base and multiply the powers. So 2 to the 1 times 3 power gives you 3, 2 to the 3rd power. 3 to the 1st raised to the 3rd is 3 to the 1 times 3 power, which gives you 3. So you have 2 to the 3rd over 3 to the 3rd. That's it. You apply that power to both the numerator and the denominator, and then you can simplify further if you would like. 2 to the 3rd is 8, 3 to the 3rd is 27. That's your answer right there. So our rule here, if we have a over b raised to the n, we could write our rule as a to the n over b to the n. And b can't be 0. So that's our last property here. Let's do a few examples. 1/2 to the 3rd power. We saw that one a second ago, but let's answer it fully again. So 1 to the 3rd over 2 to the 3rd. That's 1 cubed is 1, 2 to the 3rd is 8. So 1/8. X to the 5th, or x over 3 raised to the 5th power. So again, I want you to think of this as the 5th power going to the x to the 1st, and the 5th power going to the 3 to the 1st. So the result is x to the 1 times 5, which is 5, and 3 to the 1 times 5, which is 5. So 3 to the 5th power. That's how we would do that. X to the 5th over 3 to the 5th. Next one. N to the 5th raised to the 4th, and then we're going to have 2 raised to the 4th. I want you to think of this as a 2 to the 1st power. 2 to the 1st power. Okay, so when we simplify this, n to the 5 times 4 is 20, and 2 to the 1 times 4, so 2 to the 4th power. That would be your answer there. And if you're wondering how to type something like 2 to the 4th in your calculator, use the caret button on the left-hand side. 2 caret 4, 2 raised to the 4th power. That's going to be 16. So n to the 20th over 16 would be the most simplified version of your answer. Why don't you guys try the 3 try problems on the bottom? Go ahead and pause this video and resume once you have those 3 answers. Here are the first 2 answers. I didn't work out the last one yet because I'm going to work that one out in live time. But the first 2 try problems should be 16 over 81 if you simplify it, and the second one should be x to the 18th power over 2 to the 6th power, which is 64. For the last one, it's like, again, you have 2 separate problems here to deal with. I would simplify what's inside the parentheses first and then go from there. So I want you to kind of think of this as one problem right here and a second problem right here, your x's and your y's. So if I think of x to the fifth over x to the third, what does that simplify to? That simplifies to x to the second, right? Because with division, we keep the base and subtract the powers. Well, what about your y's? Y to the second over y to the first. 2 minus 1 is 1, so that would just be y to the first power remaining. And that's all still raised to the fourth power. We're just going to carry that 4 down and put it right there. Now we got a problem that we've done before. We've done a problem like this before. So we're going to apply that fourth power to both the x and the y. So this is a power of products. So our result is x to the 2 times 4, which is 8, and y to the 1 times 4, which is 4. So x to the 8th, y to the 4th would be your answer for that one. So again, simplify what's inside the parentheses, so do that division problem, and then raise it to the exponent after would be my best suggestion. All right, are you ready for some mixed review? Hopefully so. Feel free to pause the video, try the problems on your own, and then resume it. Or if you feel like you need some guidance on these questions, feel free to just watch this video right through. So for the first problem, this is the first property we learned with multiplication. Remember, we keep the base and add the powers with multiplication. So 8 plus 3 is 11, so that would be x to the 11th power. Notice how this problem right here is different than this problem right here. Notice that this is just multiplication, while this is a power raised to a power. Our property is different. The 8 and 3 are the same, but what we do is different. If we were to expand this out, it would be x to the 8th times x to the 8th times x to the 8th. 8 plus 8 plus 8 is 24. So that's one way of thinking about it, or the shortcut version is multiply 8 times 3, which is x to the 24th power. Next one, x to the 8th divided by x to the 3rd. Property here, keep the base, subtract the powers. So it would be x to the 5th power. Ooh, next one's kind of interesting. So on the top, you have something here to simplify. I'm going to simplify that top first. That's going to be 7 to the 16th power. And then I'm going to write divided by 7 to the 10th power. And if I simplify that further, I keep the base, subtract the powers of 16 and 10, and if I subtract those powers, I get 6. So 7 to the 6th power would be your answer for that one. Let's keep going. Notice here I added in some coefficients. So the same types of problems, but I added in some coefficients here, like the 3 and the 9, and a 2, and a 10 and a 5 here. So what do we do with those? When we have coefficients, we do whatever the property tells us to do, or whatever the operation tells us to do. So in this case, multiplication, we're going to multiply the 3 and the 9. And then we're going to apply our exponent properties to deal with the x's. In the next one, we're going to take our 2 and raise it to the 3rd power. And here we're going to divide 10 and 5. So let's go ahead and do that. So for the first problem, 3 and 9, 3 times 9 is 27. And x to the 10th times x to the 6th is x to the 16th. So that would be my answer for that one. Now, if I look at the second one, most kids will put 6x to the 21st. Is that correct? No, that 6 is not correct. We don't do 2 times 3. Think of this 2 as 2 to the 1st power. We have 2 to the 1st power raised to the 3rd power. So what we really have here is 2 to the 3rd power. Well, 2 to the 3rd power is not 6. 2 to the 3rd power is 8. So we have 8x to the 21st power. What about the next one? 10 divided by 5 is what we have to do there because it's a division problem. Treat it like a fraction. 10 divided by 5 is 2. And then we have x to the 9th divided by x to the 5th. X to the, keep the base, subtract the powers. So x to the 4th. 2x to the 4th would be your answer for that one. Next one is a power of products. We have 3 to the 4th times 7 to the 11th raised to the 2nd power. So we're going to take that 2nd power and we're going to apply it to the 3 and the 7. So if we do that, we keep the base. Power raised to a power, we multiply. So 4 times 2 is 8. So 3 to the 8th power times 7 to the 11 times 2. And that would give me 22. So 7 to the 22nd power. And for the last one, I have a blank here I need you to fill in right there. I have z to the 9th g squared raised to something equals z to the 27th g to the 6th. There was something like this on your quick check a couple of days ago. So because it's a power raised to a power, you know that this number times this number has to equal the new answer, which is 27 in this case for the z's. And similarly, this number times this number has to equal 6. Okay, well that number, that mystery number, is going to be the same in both of those scenarios. So what times 9 gives me 27? 3. So 3 would have to go here. Let's see if that works for the g's. 2 times 3, that gives me 6. That checks out. So the blank would have to be a 3 in that case. Okay, last problem for us today. We have a big quotient here, and we have to simplify this. So again, I kind of want you to think of splitting this thing up into a couple different scenarios. You have a 9 over 12 fraction to reduce there. You have an x to the 10th over x to the 1st to deal with there. And you have a y to the 7th over y to the 3rd to deal with here. Let's deal with each of those individually. I'm going to copy down my quotient, my fraction bar, and I'm going to look at my 9/12ths. What does 9/12ths reduce to? Well, you could put in your calculator, 9 ABC 12. It'll reduce to 3/4. So I'm going to write 3 over 4, just like that. Now I'm going to move on to my x's. X to the 10th over x to the 1st. 10 minus 1 is 9, so x to the 9th power up top here. And then y to the 7th over y to the 3rd is y to the 7 minus 3, which is 4, so y to the 4th. There's my answer right there. Okay, I couldn't help myself. Just one more little quick one to bring it full circle back to what we started with today. How would I simplify g divided by 3 cubed? Think of this as g to the 1st power. Think of this as 3 to the 1st power. That's the first step. If you don't have a power, it's a 1, so write it in there. If I simplify this, it's g to the 1 times 3, so that's 3, over 3 to the 1 times 3. Keep the base. The 3 doesn't change. 1 times 3 is 3. So if I simplify that, g to the 3rd over 27. 3 to the 3rd is 27. So that would be your answer for that one. So now we've officially brought it full circle. So I feel better now. We can be done. And you need to go in, and there's a review assignment. It kind of meshes together some of the stuff we've learned today and the other stuff as well. So it'll be a good way to synthesize or summarize kind of a lot of the things we've been talking about over the last week or so. So give that a shot. You have unlimited attempts. Reach out if you need help. Thanks for watching, and be well.